This is going to be a great service call. It's the day after Thanksgiving. We're closed for the weekend. We have a new customer, residential, that's got no heat, and he's a mechanical engineer. Those are the best. Let's go. What's going on, ladies and gentlemen? Thank you so much for tuning in. Friday morning, a little before 8:30 here on November 29th, 2024. Heading on an emergency no heat service call that came in late last night. I gave him the rates. I was like, listen, let's go tomorrow morning. It's not that cold out, and we'll get your heat up and running. The entire team has the Thanksgiving Day weekend off. So on Wednesday, I try to send him home a little bit early. So Thursday, Friday, and then Saturday, Sunday. So a nice little 4-day weekend for the entire team. And continuing with my philosophy of leading by example and do as I do, not as I say, I'm running the service calls myself. Let's go see what's going on with his Weil McLain gas-fired boiler that's on the fritz. Oh, okay. Good morning. I'm Mike.
Good morning.
That's got a...
Oh, excellent.
We wipe our feet on our floors.
I want
on our
the
carpet.
people who wipe their feet and actually bring their own rug too while they're at it.
Yeah,
that's
probably not going to clear the door, so let me just move that up a little bit.
Yeah, that's good.
Now, we understand you have no heat.
Yeah. Here's the deal. I'll lead you down to it.
Okay, please do.
Okay.
I see you have a couple thermostats here.
Yep, the left one is the heating. It's normally set to 57, so if it's something we're testing and you want to come upstairs,
Okay.
just set it.
And right now you have it off.
Yeah, I turned this thing off. It got up to 57. I said, you know what? He's coming anyway. Let's make it a situation where it's got to be
Here you go.
on. All right. While we're talking, I cleaned the burners even.
Wow.
What's going on? Yeah.
Good for you.
First time in owning this house for 30 years. I cleaned the burners.
Okay, I didn't hear the click, so there's the click. Okay, the thermostat relay inside for the heating circuit. I heard that click. Okay, let's go see the board.
So we do the drain top at the bottom, all right? I did the simple maintenance.
Yes, sir.
Last couple of seasons, what's been happening is, when I started up, it wouldn't come on. And what happened is, it's really weird. I might as well tell you this. It's like a little troubleshooting. I took it off just as a matter of course, and all of a sudden the thing came on. It started happening last year.
The cover.
Yeah.
So the cover off, and then it popped on, like giving it a swift kick
It might
in
be
the butt.
Yeah, I said, what, the draft isn't right or something? I said, I'm not a professional, but I'm an engineer by profession. So
Here we go.
Not recently, but I'm a mechanical engineer by training. Anyway, so you can really talk to me some of the. So anyway, to jump through, I got through last season, no problems, but I kept it I kept a little bit like this, just so I had like a little something in the ear, and it was fine. It cut through.
Yeah.
This
Do you
year,
know, since you self-disclosed that you're a mechanical engineer, right? Let me show you something. Do you know that, you definitely know that, do you know why that cover sits the way it does?
I'm sure it's designed.
There you go. See,
Yeah.
okay, I appreciate
Yeah.
that. The openings on the top and the bottom that the cover allowed to have, like on the top here and the bottom there, are all engineered. To allow for proper draft and the convection of air, hot to cold. So Okay, very good.
Yeah.
All right, very good.
It's something to do with the draft, maybe. All right, so then jump ahead. This season, again, immediately had a problem. The little thing I was using to hold it out, so I said, oh, all right. I took it off totally. I said, this thing seems like it needs more air or something. The mix isn't right, whatever. Mm-hmm. And it was working. I think one other time I had here's another weird thing. This is gonna. And then I walked in and said, let me just try. I'm embarrassed as an engineer that I do stuff like this. So I go and I put the cover on, and then it turns on. So it's backwards, all right?
Yeah.
I don't want so much air anymore, But then it failed again. I left it off. But anyway, I got caught Thanksgiving night. Suddenly, I ain't going to come on no matter what you do. You can play around with me. So here I am stuck.
You have you got a pilot.
Yeah, it's not really old system.
You got a pilot, but you know what we don't hear right now?
This is the zone they're using.
Yes, but you know what we don't hear right now? We don't hear the circulator running.
Yeah, but he's very quiet. There's vibration.
Yeah?
You feel the vibration. You don't think he's on? Oh, see, feel the vibration. It's a very quiet.
Let's see, hold on. Let me turn the switch off.
Yeah. Yeah, see?
Yeah, I guess wow, it's very quiet.
Yeah.
She's a very quiet Grunfus. Yesterday morning, Thanksgiving morning, I actually took out a Grunfus Alpha 2 ECM circulator that took a dump Thanksgiving morning.
Well, my problem was I had the check valve wasn't working, so I was burning out pumps. In fact, that's the old one. The previous one, I never threw it out. But that's not the problem this time. Unfortunately, I got caught. Like, I should have called somebody. But they give the ads. We'll do the tune-up maintenance. I don't trust these guys. They're really gonna do anything meaningful for me. I already have a weird thing going on. So it's like a stupid person. I said, I'll wait till it's like really cold, and and have to get it fixed. So.
I wonder if this is let's see.
I've never touched it, by the way. I didn't play with it. No DIY crap. I said, you know what? I'll let a professional come in. If anybody's going to play with this, I'll let a professional play.
At least I play one on TV, So.
Yeah, yeah. I don't, have delusions of grandeur. I just told you as an engineer, just you can talk to me a little bit about,
Okay.
BTU or whatnot. But I'm not, I've been practicing for many years.
So right now I'm separating the thermostat connections TT to this, and
Yeah.
so you have what we call a bad fan center relay, which is this control there.
Oh, all right.
Because right now I'm telling it to turn on by taking the two leads, R and I think it's Y here.
Yeah.
And we're not doing anything. Absolutely nothing.
Oh, all right.
So
all right,
unless the transformer is dead, which it's not because you said touching it, and the transformer is, that's the relay of that relay. But you have, let's see if I could try something here without killing myself. I'm gonna take out that relay. Oh wow, it's just not even barely. All right, whatever. Interesting. What do we got going on here? Okay. Interesting. So we have something interesting going on here.
Whatever
let's
it is, I didn't
hit
do
that
it. I
switch
didn't
on there.
jury rig anything.
Turn that switch off?
Oh, sure. Oh, let's switch. I'm sorry.
Okay, yeah. Huh.
Last time some pro touched this was when the guy put in second zone for me. That's,
So here is 110 volts at the neutral for the transformer. We have to get my tool bag. I have to go inside there and see. So this was not, I don't know if, maybe it was connected to here.
Wiring,
I don't think it's, why would it even be connected to there? But this, I got to find out what the deal is with this. So this yellow wire, could it be neutral? No, I don't get that. This is not connected to something for a reason. Either it got disconnected or what have you, but it does kind of make sense that you were, taking the cover on and off, and it corresponded to the system turning on and off. But the two, let's explain how things are.
Yeah.
You have two circulators that are getting power exclusively from the two-zone switch, or the switching relay that's here. So the switching relay gets constant power. It gets a signal from the thermostat to turn on. When it gets a signal for to turn on, that 24 volts closes that relay and sends 110 volts from the line or the source into the load. So if zone 1 is on, zone 1 load is getting power from line, and then that circulator runs. So the circulator runs, however, you also need 24 volt circuitry to power the low voltage controls here, like the gas valve. Even though these are switches, this is an Aquastat high limit switch. It still has 24 volts going through it, and then you may have
it's
even
a
have
water temperature, right? That's the
but your system is actually very simple. It's only giving power, the transformer, to the gas valve as long as the high limit switch is in the closed position. Right? You don't have a rollout switch. You don't have a spill switch on the draft diverter. It's a very simple boiler. You have as simple as it gets, right? Because if you didn't have the high limit, the boiler would run until it's told to turn off, right? But you don't have a steam boiler. You have a domestic, 180-degree cast iron boiler for hydronic purposes.
So it's got limits. It'll turn off above 180. It'll
So let me get my tool bag, and it looks it's going to be as simple as wiring the neutral to the system here. Right. Hopefully. We're going to take a look inside this switch. I want to see, because there's 2 wires there, all right? And I want to see what's up with that other wire.
All right.
Okay, so I'm going to take out these screws. I know the switch is off here, but let's see what's going on back there. All right, so we have, by the way, do you have any idea who invented the slotted screw? That is the most stupidest thing in the world. The guy Philip, when he came around, that guy Philip probably was king, by the way. He put this guy out of business. But they still make flat screws. You can't work with these. All right, let's take a look here. We have line, probably, L1. And this is neutral coming from our power source above, which goes there. And that's probably going to the switch at the top of the stairs and or the circuit breaker panel. So this is line. And let's verify we have power there. Okay, so power's on this line. And this is our neutral. Now, there's that one we're trying to figure out. Leaving the switch, we go through here, and that feeds our switching relay. And the other one, which is right here, oh, look at that. See? So they created a pigtail. So leaving the switch, we have, it goes 2 places directly from the switch. One is the switching relay. I don't know why they did that. And the other one is here. So the 2 black lines, one is to our transformer, and the other one is to our relay. But our neutral,
and the white should be the neutral, right?
Yep, our neutral, let's get that neutral in there without causing any other. Okay, so there's our neutral. Now what we're going to do is, this neutral is coming from this is our line neutral. This is our neutral going to the switching relay. And here's the neutral going to our transformer. So we need to connect those 3 together and pray for the best. All right, so I have, this is that neutral coming from line, neutral going to our relay, and neutral going to our transformer. So all those are in there now.
Oh, I've never seen one of those. Okay.
This is called a lever connector by Wago. It's a European brand, but you'd appreciate this. This is a traditional wire nut for a certain gauge of wire, right? It's technically only should be used once. Technically speaking, right? This is a Wago. This is the model 221 lever connector, and it has these levers, and this is for a 3-conductor wire. For certain gauges, right? You put the wires in there, you push them in, you go like this, and guess what? They are not coming out, and they're reusable. Pretty cool, huh?
That's for a range of gauges.
Yep, range of gauges. They make larger ones, but and believe it or not, this will handle, I guess, amperage or the current up to about, it will melt at around 150 amps. That's pretty impressive. Yeah. Right? That's pretty impressive. A client of ours who's actually, his business title at his office is Site Reliability Officer, Google.
Oh.
Yep. That's his title, his business title. And he actually has his letter from MIT denying him entry, about 20 years ago, 30 years ago, framed at his office at Google.
Yeah,
it's like if they only knew. He's a very, very nice guy.
least he's never chipping his shoulders.
Yeah. All right, so I'm putting this back together now. He's a really nice guy. But he showed me those. Okay, so there's that. Let's put this box back, this Fang Center relay back on the 2 screws there, and then we're going to play some games. It's a very good system. You have a CGM5, it looks like, 140,000? Yeah, 140,000 net gross input. As you said, putting efficiency aside, and when we're done and this fires up, I'm going to tell you exactly what the efficiency levels of this boiler is because I have this tool right behind me. But putting that aside, until this leaks internally with the heat exchanger, it'll run forever. You'll replace components, and the only thing that's really been replaced from original install that it looks like is probably this circulator. Yeah, that's not the original circulator. Right. That gas valve looks original. Yeah. That fan center relay looks original. This is probably not original. Probably not.
I don't remember that.
It's from 1980, so that I don't think is that doesn't look original. But this expansion tank, I'm willing to say the expansion tank is original too.
I'm almost certain that.
Right?
Yeah.
There's actually a serial number on there. There you go, 212355586. That's the date code. 86. When was this being put in? I know 80. I don't know. All right, but so because you had mentioned taking the cover on and off, and it did things to the boiler like work. Every connection that I'm working with, I am upgrading the wire nuts to that and recutting the insulation off and doing that. So we have.
So at least whatever else happens, it shouldn't be due to bad electrical connection.
So right now I have the power on. Yeah. This was that TT connection, and this is coming from your relay, right, which will turn the boiler on, the end switch. Okay, so let's put this together. Right. So do you want to hold that for a split second? Because I like to feed people education. So if I put this in there, we have ignition. Okay? And if you were to turn off that turn off the thermostat upstairs, that will turn this relay off, and the boiler should turn off. So right now the boiler's running.
Good. It can't run immediately, which I can see, obviously.
Yes. And if we were to, let's say, just remove the wire for the I don't want to go into there because, again, this is X amount of years old. So unless I suspect a problem, I'm not going to go into it. So you had asked earlier, if during a tune-up. Now, there are tune-ups that a lot of plumbing and HVAC contractors do that unfortunately are not worth anything. And there are tune-ups, and I'm not to brag, or tune-ups by my company where we spend, on this system, an hour and a half on a year. Would we have found this wire being loose in there? Unless I suspect a problem, there's no reason to go into that switch, right? When we're checking central air conditioning systems. I am not hooking up my gauges to test the Freon or the Purine or the refrigerant levels unless I suspect there's a problem. Because believe it or not, 9 times out of 10 with air conditioning service calls, Freon or the refrigerant is not the cause. It's always an electrical problem. And I learned that from a great man named Eugene Silverstein. He taught me HVAC.
Yeah, my last repair was a relay on the train system.
Yep. So let's take a look at some just components here. Right here is our relief valve. This should be a 30 PSI relief valve, and it is. Okay. This is an automatic air valve. Weil McLain, this model, which has been replaced by the CGA, always has that 1/2-inch tapping right next to the 1 1/4 coming out of the top of the boiler. That's for your automatic air removal. Coming out of the top, you have 1-inch copper, and then it goes into 2 zones here. 1 3/4, 1 1 inch. The 1 inch is your main zone. The 3/4 was an addition later on. Boiler drain. You have the circulator for zone 1, circulator for zone 2. Tridecator. Actually, it's tridecator gauge. No, it's not a tridecator gauge. It only has 2 dials. One is pressure, one is temperature. That's an old
Can you verify something for me?
Yes.
I always make sure when I do the drain when I start the season, I bring it back up to 12, and then it heats up. Of course, the pressure goes up. But I start at 12 because it actually tends to dip below 10.
So here's a common misconception. You said at the beginning of the season you drain the boiler out. There's no need to touch anything in the boiler, unless there's air being introduced into the system during a service, so something was disconnected, the system was repaired, the system was drained, refilled. You don't need to take the water out and replenish it, right? It's a closed system, and unless there's a leak, that automatic feed valve there will just maintain pressure.
But let me ask you a stupid question. This thing normally over when I turn it off, over the summer and everything, it goes down below 10. And I always associated that with like a malfunction in the way it works, circulating.
Goes below 10?
So yeah.
Okay, so
let's pressure.
Yeah, so let's talk a couple things. Number one, we don't know how accurate the temperature and pressure gauge is.
All right.
Number two, you have a 40-year-old expansion tank, right, which normally lasts 7 to 10 years. Right, so if you look at it the wrong way, it's gonna like just explode. I'm just joking. You have a pressure regulation device called the pressure reducing valve over there. That's also 40 plus years old. Be careful touching anything, because there's reasons why I don't like touching that lever there, because they start to leak. When it's been holding back 40, 50, 60 pounds of pressure and giving only 12 on the outlet side for 20 years, 40 years undisturbed, you would touch that, it may not want to turn off. It may want to leak. It may not do anything. Say, hey, listen, I'm comfortable here. I'm only giving 12 pounds.
So here's my backup question then. My impression from just briefly reading the manual was it's also to drain just a little bit of sediment, just like a low spot, supposedly.
Yeah, nah. I professionally, I wouldn't drain the water in the boiler. Right. I wouldn't do anything to it, unless you have like swishing sounds, because that's air is in the lawn, things that, and it's interfering with circulation.
Some I can drain upstairs right through the.
Yeah, but I wouldn't. I wouldn't touch anything with it, to be honest with you.
So you're saying basically your default would be start it up, just make sure it starts up and everything. And,
yes.
All
right, I drilled a hole approximately 6 inches off the top of the boiler between the boiler and the draft diverter. That is for our combustion analyzer. And the probe is halfway into the flue piping. Take a look at our numbers. We're almost at 500 degrees of stack temperature, and ideally high 3s to low 4s of hundreds. O2 of 9.0 and dropping. Carbon monoxide, 28 parts per million. We have an overall efficiency. This is what you were asking about before. Like, besides efficiency, when do you replace the boiler? How much more time you think is left to it? How much more time? Listen, until the boiler has a hole in it, crack, leaking water from the heat exchanger, besides efficiency, you can replace parts on it. But here's something to consider. For every $1 of fuel that you burn right now, only 77 cents is heating your home. So
77%, yeah, okay.
Yeah, and to put it this way, the waste temperature or the stack temperature leaving this boiler is 565 degrees right now.
That shouldn't be that high, right?
No. It should be in the high 3s, low 4s. Yeah. This is more approaching oil territory. Oil-fired equipment. There's a lot of wasted heat there. And again, I'm not an oil expert by far. I don't know anything about oil. Let me just say that. But that stack temperature, I've been told, is oil territory. A boiler like this, a Weil McLain, like CG something gold oil-fired boiler, I was told you have in the high 5s. And that's the reason why, with gas-fired equipment, we need to install a UL-listed stainless steel chimney liner when we convert a home oil to gas. Because in our area, the chimneys are lined with terracotta lining. Mm-hmm. The exhaust temperature of an oil boiler will not ever condense by the time it gets to the top of the boiler, by the time it gets to the top of the chimney, resulting in condensation, acidic condensation, eating away that terracotta. On a gas-fired boiler, which is significantly lower, we shall line the chimney, because what will happen is condensation will form as
to start with.
Yes, it's a low temperature to start with, and by the time it gets out of the chimney, it's already most of it. Maybe some of it's turned into a condensate already, and now that's very acidic. It eats away the terracotta lining.
That's the condensate you capture, because the last guy said to me, I got to put a condensate.
No. So on high efficiency equipment, right, where you have condensing boilers, right, you will have condensation as a byproduct of combustion. As it immediately at the source of creation at the boiler itself.
Oh, right, gotcha.
Right, so, but also when it discharges out of the house in a PVC pipe or a polypropylene pipe, it it's already condensing, so that's why we have it pitches outside sometimes, or pitches back to the boiler so it can go into a drain, like a condensate neutralizer pump, or for safe discharge of that condensate. Condensing boiler. You don't have a condensing boiler. You have a cast iron boiler that thrives, or that wants 180 degrees of heat. I can lower this to 165 and play it safe, but the lower I make this number, the lower my return temperature could be as it circulates back to the boiler.
Okay.
And if I go into dangerous territory at a certain threshold, when it gets too cold to the boiler, you'll shock the boiler and it'll condense at the boiler, which is cast iron, and you'll eat the boiler. All right.
Like it rushed out the boiler.
Yes. Yeah. So let's say hypothetically, a few years from now, you decide you want to replace this boiler. Okay. You could theoretically put in a wall-hung condensing tankless combi, right? The latest and best, right? And you'll have to have it serviced every year the way a regular boiler should as well. But you also have to descale it, do this, do that, and the third. However, you don't have a low temperature heating system in this home. You have a system with baseboard or radiators that needs 180 degrees of water, typically, to properly heat this home. Because back when this house was built in the 60s or 70s, right, grossly oversized systems were put in all the time. It didn't matter what size the boiler was because no one cared about the cost of energy, because energy was cheap until the embargo happened in the late 70s, right? But you need 180 degrees of water. Yes, I could theoretically, use new technology and put sensors outside which measure the outdoor temperature. So when it's 45 degrees out, you don't need 180 degrees of water. You don't. You really don't, right? The boiler will run longer, but at a certain threshold, it won't go below that because you risk damaging the boiler. So then you can put a tankless combi in, for example. Tankless combi thrives, because it's a condensing boiler, thrives at a low temperature. But I can't heat this house with 130 degrees of water year round. I can't. Because it will be cold on those 30-degree days. I didn't mention 20 degrees. I said 30-degree days.
You're saying this is a characteristic for somebody who has baseboard?
Yes.
It's a characteristic.
So characteristic of baseboard, you should have 180 degrees of water. Listen, I could theoretically give you a tankless combi here, a high-efficiency boiler that modulates, that condenses, that doesn't use your chimney, that gets rid of this water heater, gets rid of this boiler, and it's one box that conveniently sits like one of these pieces of wood right there on the wall, connected to everything.
It's so efficient, you don't need to expel the flue gases.
Well, you have to go outside with the exhausts anyway, but it doesn't need a chimney, right? It's very efficient as that. But however, if you have it set to 180 degrees, what's the game? What efficiency do you have there? Nothing. You'll have instead of a 613 exhaust temperature, you'll have 120, right? And look at it, 615 degrees, 61% efficiency. There's the numbers right there. Crazy, right? And I didn't even look at CO2 yet. Okay, that's good, 7.4. But these numbers, let me just clipboard this because I want to do the draft as well. I want to pull that out. We're going to go escape. Oh. And let's go down a number to draft. I'm going to see what our draft is. So let's say, for example, I have a condensing tankless boiler in my house. I have a mix of roughly 50% radiant heat, which is in-floor tubing, which needs 120 degrees of water to heat the house, and baseboard with convectors, kind of like what you have, and which needs on cold days 180 degrees of water. Okay, I have that system year-round set for 145 degrees. My house is also well insulated, but on those cold days when it drops below 30-ish degrees, I got to jack up that temperature, but I won't dare go above 165 because it defeats the whole purpose of having this tankless boiler, which is condensing in nature, and it thrives at that lower temperature. If I might as well put a regular boiler in. So here, if you needed to replace the boiler, you're going to get another Weil McLain boiler, right? Because I love them. I think they're great boilers. For cast iron.
So I can still find a conventional.
Yeah, absolutely. Well, yes. Yep. And we have great draft.
Most likely what I would do.
Yeah, we have great draft. Problem solved. What I want you to do is turn off that switch or the thermostat. I want to make sure it turns off, and then we're good. All right, ladies and gentlemen, this concludes the video of the service call. For reference, when you call Pipe Doctor Home Services for any heating service call, if we're working on the system, Our objective may be to get the heat up and running for you, and so it's operational. But our objective is to make sure it's burning properly and safely. What good is a functional boiler or furnace or heating system if it's not running safely? At the end of the day, plumbers protect the health of a nation. Thank you so much for watching, guys. Hope you all have a great day, evening, or night, regardless of what time of day you're watching this. Thank you so much. And the best way for you to support this channel would be to subscribe to the channel. It's free, there's no cost. Hit that subscribe button down below. You can hit that bell to get notifications when I drop a video, which is every single day. And let me get your thoughts and feedback in the comment section down below. Thanks a lot, guys. Happy holidays.